Good evening, everyone. I hope everyone are doing great. Were everyone able to see my screen?
Yes,
Okay. So I think we have enough people to join the session and we have to start the class for today. All right. Welcome back and hope you had a wonderful weekend. So the last session we had, that is for storage, right? Simple storage service. And we have discussed about few options and the permissions levels. And we try to create a sample websites, static website hostings, and we have looked at the replication policies and file movements and different types of upload options within the storage level. Okay. And that's what we have tried to do a lab sessions as well last time. I hope everyone are clear with that topics. Any doubts on the last session? Are everyone clear from the last session? Any doubts? And if people who have missed it, so I would suggest to please try to go through a recorded session from the LMS portal and try to see the previous classes, what we have completed. That should help out. And you can try to have some notes with the free tier account based on our understanding on the charges. For the free tier account, please try to use those services as recommended during the class sessions. If anything apart from that, if you try to do any happening, okay, just please make sure on that part. All right. So as we have completed with the cloud fundamentals demo and compute services, storage services, today from now we are going to start with another module, that is networking. Okay. So that's again one of the main important aspect for the cloud infrastructure. And we are going to discuss about the basics, understanding, and we are trying to see of what are the different type of options available within the cloud for the AWS. So we'll try to see we'll try to have a lab sessions as well for the sample lab sessions, how the network is important, how it is configured to have a server launched, correct? I hope we have, during the compute sessions, compute classes, we have tried to launch the servers, like different servers like Windows and Linux. So to have any server or any computer launched, it needs a network, right? So nothing works without an IP address and without the internet. So that all topics will come under the networking modules. Okay. Let us try to understand more. Right. Let me pull some notification. So before we go through, we need to understand what is actually a networking. So I hope you people might have heard, maybe your during your learnings semesters, and it might be a part of a subject for the computer graduation people. And some people might, they might have a knowledge from the outside the blogs or over the internet, like if networking must be the term which you might have heard of, correct? So how it is going to be an aspect and how it is going to be helpful in the cloud environment, right? So in today's technology oriented world, so sharing or communication, that has become an integral part of a business and other activities, correct? So that sharing can be achieved by the networking. So the data sharing can be achieved by the networking concepts. So the communication should happen from one location to another location or one device to another device. So a computer network is linking two or more computers in order to share files or the resources. Okay. In general, the computer in order to share files or resources. Okay. So before I just jump into actual networking from the cloud, I just want to make you understand about the basic level as well, so that will make you feel just go through into the class and try to understand the technicalities and what is a general networking concepts. Okay. So it is kind of establishing a communications between two devices and sharing of data from one location to another location or from one end to another end, like a source to destinations. So how it's going to be helpful? You people might have a personal computers as well, correct? So you can see how the files can be shared from one computer to another computer. So network enables user to share files with others, correct? For example, uh, in a particular company, if one person like IT admin, he want to upload a software to a different systems. So how it's going to be done? He wants to install some operating system. There are 100 systems. There is a one infrastructure admin, like an IT admin, we can call that as, correct? So how he's going to, like one or two persons in that company, he cannot try to go to that each manual computer and go to their system and try to sit down and try to copy with a USB or a pen drive, correct? So how it is going to be achieved? He just try to create a network. And then within that network, he'll try to push all the files over the networks. So the communication between one computer to another computer can be happening with a computer. So he can try to share all the files from one location to another location with the help of a network, right? So with the help of a networking systems, he will give access to other computers, so that with the help of an IP address, he'll give an IP address, he'll go to that computer and then try to access that. So all the computers must be located under one single network, so that the sharing can be possible. So within one single network, the sharing can be possible. Okay. So that's how it is going to be helpful as well. And it is also trying to be used in general. We can try to see where printer devices and hard disks, where the networking will be enabled, and you can try to access those devices to print your pages and the documents as well, right? And it will try to improve communications. Usually the network concept also improves. It improves the network communication speed and accuracy with a less chance of messaging being lost. So that's how it's efficient. So the cost of transfers of these files using computers associated with the network is less expensive than the adult traditional means, like any physical data transfer, like from either through a physical devices. Okay. And it's a highly reliable as well. So without any hardware failures and without the issues of any other connectivity issues, we'll be able to transfer our communications with the help of a network when all the computers are linked with a one network. So this computer networking concept will be implemented with an IP address configuration. So that's how it is going to be helpful. So what are the different types of things which are available as part of network? We'll try to understand. Okay. You people might have heard, right? When you try to purchase a computer, it has to be assigned with some particular private IP address and public IP address. You might have heard that, right? So we'll generally go with this private IP address, IP address. Any idea on what is the requirement of public IP and private IP? Can anyone try to confirm over the chat just to make session interactive? What is the difference between private IP address and the public IP address? You people are actually trying to use it daily, your computers and the laptops. You should actually have an understanding. Why are we trying to use an IP address, your computer? Anyone? Just want to make sure if you are following the flow, and that can be interactive for us as well to understand the concepts that should help out our doubts and clearance, because network is an important concept as well. Okay, someone said public IP address is used to connect to the internet. Okay, that's correct. So that they can retrieve, download, and share the content over the internet. Okay, that is fine. So what is the requirement of a private IP address? Anyone? I've got a response for the public IP address from one of the person. What is the need for private IP address? For example, even if I had a computer where I should have a private and public IP address configured. For example, even if you try to open, for example, simply to check any private or IP address assigned to your computer, you just go to there, type IP config. I'm typing IP config /all. Okay. You can see it has been assigned with some particular details. This IP config is a command when you can try to open CMD command prompt from your start button. And if you type IP config /all, it will try to display all the network related information that has been assigned to your computer. Okay. So it will generally try to show you the IP address, the DNS, and the DHCP, and the network related aspects, and the MAC address, and everything will try to show up here. So for here, you can see in my system, it is trying to show up the private IP address as well. What is that? It is telling 192.168.0.104. So this is my private IP address. What is the need? What is the need for the private IP address? Usually, anyone? I doesn't got a response from others. If you try to understand this, then you'll be able to concentrate on cloud environment. So that will be a tough job for you to actually try to go through. Anyone? It doesn't got a response yet. So private IP address. Let's devices connected to the same network communicate with one another without internet. Okay, so it's a unique IP address without the internet. This private IP address is used to communicate internally. Okay, this is for internal purpose, and the public IP address is for the external purpose, right? So for device, at least your computer is at least have an access to be assigned with one private IP address that should be assigned to be having a communications within internally. Public IP address is something if you want to go outside of your computer, like over the internet, that you need an access to over the internet. So to have some resources download over the internet, then public IP address comes into picture. Okay, so this command prompt CMD, if you type that, you'll be able to find out the private IP address information configured over there. You can see that, right? So that will be showing all the information related to that. Okay, so what are the different types of IP addresses? Okay, and as we have seen, these are the different types, and we have a different classes. So how these IP addresses are ranged? Okay, different classes of IP addresses. What are these? We have a different classes, that is nothing but class A, class B, class C, class D, class E. So you can see any IP address had 4 notation, right? 4 octets. That means, for example, you might to see the one example which I had here, my system 192.168.0.104. So this is nothing but an IP address is nothing but a 4-octet bits. So which is actually compromising and telling that's an IP address. It's kind of a 4-octet system. Okay. So you can see there are 4 bits occupied here. And we have a 6-bit as well. So that is nothing but a MAC. We have a 6-bit as well. can see this. Should be some. Just a minute. We call this as IPv4. Okay. Because it has 4 bits. And we have IPv6 version as well. That is actually configured with a MAC address actually. Okay. So it will having a 6 octets, like it's kind of a 6, like it is included with some kind of a numerical values and the MAC values, MAC address values. It is nothing but it's a 4 octet currently which is in use. And even the 6 octet MAC address IP version is also coming. It's a version 6 because it will have a 6 octet. So rather than 4, it will be trying to have some more like 6 octets. Okay, with including the MAC addresses. So that is nothing but IPv6 version. So which we are not trying to actually complete implemented as of now. When complete this IP address, because entire world is trying to use it with a one system that is IPv4, right? If complete IP addresses are exhausted, then in future, the technology is going to be implemented with an IPv6 version as well, where it will having a 6 octet bits. Okay. So why this IP address is needed? So if our device indirectly connects to the internet by connecting the first to a network to the internet, when the grants, it actually grants access to the internet. So then IP address is actually needed, right? And we have a different types of a set of IP addresses that has been designed, and each purpose, like each classes, like why these different classes of IP address are needed, we'll try to see. Okay, because it is actually to have an easy identifications, like what kind of an IP address is assigned to your system, and to know like which range the IP address has been assigned. So just to understand that, they have been designed into different classes. Let us try to understand what are the different classes of IP addresses over here. So for the class A, we have IP addresses that is ranging from 0 to 127. So any IP addresses which is starting from 0.0.0 and 2.3 until the 127.64.0.0. So any IP address which is ranging from, if you are trying to see the 192 symbol here, right? If you are trying to see any IP address starting from 0 to 127 as a first octet, then it will be belong to the class A. Okay, that's what it is mentioning. And here, the class B is notated with 128 to 191. So any IP address which is starting from 128.2.0.3 and 129 and 170, 189 and 191 till 199, if any IP address it is starting with that range, then it is class B. So MAC address is nothing but it's kind of a unique identifier. Okay. In terms of network address communications, it is kind of a unique identifier, and it is kind of a 12-digit hexadecimal number. So it is one kind of a format to have assignment of IP address as well. So it includes some kind of a MAC value digits as well, IPv6. It will having a different digits, but an IPv4 will have a numbering system. Okay, you can see digits like zeros and ones and everything. It is kind of a numbering system. Someone had a question, that question actually. Someone had a question. Is that clear, right? About the MAC address? So soon it will be going to implement it, because our computer systems has been currently assigned with an IPv4 system, because it has a 4 octets. You can see 4 bits, right? 1, 2, 3, 4. So this IPv6 version 6, it is coming sooner stages where it will be including with more 2 octets, which is actually including with the hexadecimal values. Okay, that is coming in your future. That will actually trying to come into picture when this computer technology is run out. Okay. So coming to class C, what are the different IP addresses which is starting with the range in class C? We have seen class A and class B. Class C is coming to 192 to 223. 192 to 223. So any IP address which is starting from 192 to 223, then it will be coming into class C. Okay. And class D is actually left with 224 to 239. Okay. And class C is actually designated with 242, 254. So this is kind of a different IP address ranges. Now, if you can see my system, my computer has been assigned with a class C range, correct? 192.168.0.1. So it is nothing but a class B. From this, I can try to understand my IP address is a private IP address, which has been designated from the class C range. Okay. Any doubt on classes as well, understanding of classes? So except these classes, any other IP addresses will be belonging from public IP addresses only. Okay. These actually classes are designated for the private IP addresses. And apart from this, if any other classes, IP addresses which are left, those will be considered as public IP addresses. Okay. So what is the need of the private IP address? Public IP address is to have a communication over the internet, and the private IP addresses, it is used for internal communications, and we can't use these IP addresses to have an internet connection, like over the internet communications, right? So that's how it has been designated. And we have another thing to have as well, like that is nothing but an OSI model. What is an OSI model? Anyone had an idea? OSN is nothing but a open system interconnection. Okay. Just want to make sure if this basics should be understood for you. Interconnection. So what is the need of this OSI model? Any idea? So it actually characterizes the computing functions into a set of rules and the requirements that supports communication between different protocols and the softwares. Okay. So it is kind of in the networking terms, it's kind of a language. It's kind of a universal language for the computer network. So it is actually, it's based on the concept of divide and conquers. It splits the communication subsystem into 7 layers, and the layer is defined into below. I'll just try to show you what are those layers. Okay. Why these layers are required? Just to have a communication. For example, if you are going from one place to another place, so one source to another destination. So how the in-between journey is going on. So how this network plays an important role. So that's kind of a concept is required, correct? So before understanding the roots of the technicalities of this networking concept, this OSI model plays an important role to understand how this actually communication is going from one place to another place, and how the networking aspects and the communication and the technicalities has been divided into these layers. Let us try to see what are the different layers here. So we have physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the application layer. Okay. It should be a good question for freshers as well to understand what are the different types of layers, right? So we'll try to see how this layer is going to be helpful. So the communication, how it is going from? It is going from bottom to top, because if you can see the applications we are trying to use it, right? Which we are kind of a software via the web. or over the internet, or you're trying to download any software or application like kind of a software as a service. We are trying to use it in the application level, right? So how it is going to tell in that way, then I have to replace. If this is how it actually read into, but this will be kind of a going from bottom to top side, like from application, presentation, session, transport, and the physical layer. Okay, so let us try to see how it is going to helpful for a generic understanding. So application layer is nothing but it provides user interface service. It's kind of a application or a software or kind of a graphical user interface, and anything we can call it as. Okay. When the presentation is something, this provides service of translation, compression, encryption. It includes the presentations. It includes the format, how it is the information going to be presented in front, like we are trying to see any web page in the front end. So that kind of a translations, the information and the compression, the encryption and the data encryption, everything comes into a presentation layer. Okay. And the session layer is nothing but it provides time management of sessions or access. Okay. So it'll have a keep record on a sessions, how this flow of the data is flowing, going from one location to another location. And so the transport layer is nothing but it's kind of a transmission medium, I can say. It will act as a transmitter between these two, the upper layers and the middle layers. So it is trying to provide a transmission. So it will ensure it provides service from process to process delivery. Okay. It provides a service from process to process delivery. It acts as a transport medium between the top layers, the network layers to the front end layers. Okay. So why I'm trying to tell it this as a main layers, because these were hardware layers. Hardware layer means where it includes the devices, kind of a routers, switches, and everything. In the networking, it includes, actually people might have heard, right? The routers. So the routers, the physical devices will come into network layer, and the data link layer, it will comes under switches. Switches you might have heard, right? Where the different types of wires are connected, and that will try to go to any devices, that kind of a things. Okay. So I just want to make sure on that. So these are nothing but hardware layers, these three. And these three will be considered as a software layers. Okay. And the transport layer is the heart of the operating, open system OSI model. Got it? So how this, this thing will be considered network layer. So it is responsible for moving packets from source to destinations. So we are calling in the application level, in the software level, we are trying to call the information as a data, right? The data is nothing but a information that has been passed from one location to another location. But in networking terms, in the network layer, the data will be called as a packets. Okay. So in the networking terms, the data, when we're coming into the networking layer, the data will be called as a packets, right? So that's what it is trying to. But in the switches, when it comes to the switching concept, it will be coming as a frames. So we can call it as transfer of data in the form of frames. Now, in the data link layer, the devices would be switches, and the networking layer, the devices would be routers. So how the data will be communicated over the network layer? It will be in the format of the packets. In the data link layer, it will be the format of data. Frames. Okay. Now, what is physical layer? Physical layer is nothing but wires or cables simply. How the data will be flown? Within these wires or cables, this physical layer, this data will be transit. How it will be? It is a physical, it's a physical medium for transfer of data. So how the data will be looking into here? It has been given as frames, and in the network layer, the data will be in the packets. Here, the data will be in the form of bits. Bits means you can, you are aware, right? Zeros or ones. So you can understand, right? Our computer can understand the language of zeros and ones, correct? So what actually happens in the physical layer, when a wire is connected, the data in the communication is happening. In the hardware layer is nothing but it can understand only the binary language. That is either 0 or 1, right? For example, you can try to take some time and try to understand how the communication is going on. Can you try to give me a good example how this layers, like different layers of a OSI model that is actually helpful in real-time environment? For example, some kind of an application. Does anyone had an idea on example application which I'm trying to provide here? Anyone? What should be best example to define these layers? It's not about AWS. For in general, for example, let me try to take an example here. Gmail application. Okay. So you can try to take consideration of this OSI model in any real-time applications. In the backend, how this networking will work, I'll try to explain. If, for example, there's a Gmail application. Okay. If I'm trying to go from below to top, right? So how it is going to try to tell? Let us try to see that. For example, you are trying to access a Gmail applications. What happens inside that? So you can see in the application layer, I'm opening a Gmail application, correct? When I'm trying to open a Gmail application means it is trying to display a software. It is giving us a user interface software, correct? So if you go from the back end, the low level, for example, your computer is connected to, or the devices are connected to a wires. So in this layer, the wires or the cables are connected that has a transmission of understanding of the data between, it can understand only zeros or ones. So when a wire is connected, the data over the internet that is flown, it's in the format of zeros and ones. Okay. So once the wire is connected to a switches, the data will be transferred from binary language in the form of a frames. Okay. And from there, switches, this actually has been converted and it's been connected to a router devices. You can see these routers. Routers are nothing but it provides a communication between different networking devices. So it is responsible for moving packets from source to destination. The information will be in the process of packets actually, right? So what happens when I'm trying to access Gmail applications, it provides a user interface like the username and the password and the front end application you're trying to see. And if you are going on that one step above the presentation layer, it will try to display the information about all the information about the image, the documentation, the videos, and all the formats, and everything will be in transition, like the HTML web page, all the format that will be handled because it is trying to present us the information in the front end. That is in the presentation layer. Okay. So when I'm trying to open applications, how this backend flow is going from down to above. You can see I'm opening an application here. I'm trying to access the content inside. So what actually happens, that website has to be routed to some other place, right? Where that website is coming from. So how that actually is connected. So that will be a kind of a sequence of sessions. So the sequence of sessions with the sessions IDs and everything will be there within the session layer. Okay. So what happens in the session layer? It maintains connections and it is responsible for time management of that sessions. Like at what time that session has to be continued. What kind of an information is trying to pass on. That has to go through the transport layer. Okay. Everything will be coming over here in the session. It actually establishes connections and maintains the authentications and the security protocols over here in the session layer. Got it? So in the application layer, This will be kind of a application in the front end. The presentation layer, it will displays all the front end informations like the web page and the compression technologies and the encryptions and the HTML paging formats and everything will be taken care here. And in the session layer, it is trying to pass on the message to the gateway. Like it is nothing but the next thing is like the transport layer. So what is the transport layer? It takes the information from the networking layer from host to another and locate it in the different layer, and it will try to pass on the information to the session. So transport is nothing but it provides a communication between the hardware layers and the software layers. Okay. So that it is trying to pick the information from this routers. It is actually trying to act as a firewall. Okay. So that is nothing but a transport. It provides process and process delivery. So it includes the TCP and UDP process protocols. Right? So transport layer is the one who maintains the communications, which transmits the information from networking to transport layer. Right? So it will try to take the informations like in the form of packets from the network layer, and it will try to pass on the informations into these below software layers. So that's how the transport layer comes into picture. So when it coming to the networking layer, how it is the information there? Here the information is already passed on to a software information, right? It is in the form of a message. You are trying to see as a web page, the information, the images and everything. It will has been completely digitalized. The information has been digitalized into these layers, but how the backend process is going on, it is coming from transport, where the TCP and UDP is trying to convert these informations to the software. But in the network layer, what happens? The network and the routers can understand only the language of information in the form of packets. So the packets are coming from the routers. So router is trying to follow different types of routing protocol technologies. Okay. Different type of protocols are included in the networking layers, where it will be trying to have that information passed on to the router. So once this router, the information is coming in the packets are transferred to down layers. So before the packets, where the transfer information is coming from, it is coming from the switches. The switch is a device where it will try to split the information to a different devices. So switches information that actually had a ports. You can see a big switches if you go to the internet that has been connected. So it is connected through a ports. That ports has been connected to a different router devices, like over the internet, like even in the data centers and different hubs, like at our homes as well, right? Where different information is trying to come and trying to connect to the over the wires through our routers at our home. So router is trying to send out the information in the form of packets. And this router has wires, like the cables at your home, maybe the Wi-Fi access points. This routers has a Wi-Fi access points. So the information is actually passing on through wires and the cables over the packets, and the packets are actually trying to convert the information into the software layers, okay, in the message format. So the switches has a data in the form of frames, and before the framing technology, how actually the data will be there? It's a raw data. How the raw data will be in there in the form of wires or cables, where the data will be in the form of bits. Bits is nothing but zeros or ones. So computers only can understand zeros or ones. But humans cannot understand zeros and ones. When you're trying to open a Google, you cannot try to go and try to understand the language for the zeros and ones simply, right? So these zeros and ones are converted from physical layer to the down layers till the application layer. This is how the technology behind the working on in terms of networking concepts. So that's why we can try to take an example for Gmail applications. So when you're trying to tag any application, kind of a software in the front end in the browser, this is how the backend technology, where in the networking terms, that information and the data will be transferred from one medium to another medium. So from the wires and the cables, see how the data inside that particular wires, like zeros and ones, how the data is converted into a software, like a digital information, like the front end images and the videos. So the image which I'm trying to see in the slide as well here, this is in the front end I'm trying to see as a digital information. The back end, it has to be in the zeros and ones, like in the analog form. So this is how the network plays an important role on how to convert that information into digital information for users, for the human readable language to understand the application and how it works in general. Okay. So that is nothing but a different understand aspects of OSI model and how it is actually working on. These are the important things you need to learn and understand the concept before we are trying to, even in your general computer semesters, or if you're trying to go for the networking domain, these are the main important things that you have to learn about before you're trying to understand the cloud environment as well. Okay, networking is a very important concept. It's a backbone of IT, information technology. Are we clear with the OSI model concept? Any doubts? I'd see only response from one. Other people are clear. If you are not able to understand this, it would be tough to go through a cloud concept as well. So that's why I'm trying to go with a basic understanding, how it goes through. I'm just trying to tell you about the front end theoretical level, but in the back end, you can try to understand more by having that Google through and going through a blocks and going through a different articles as well. How this OSI model works and what are the different classes? Why do we need classes? What is a public IP and private? You can try to dig in more. We have a computer networking subjects as well. Okay. Are we good to understand? Any doubts? And also we have a concept for DNS and DHCP. What is DNS? Anyone had an idea? Even it comes under networking concept. So DNS is nothing but it's simply kind of I can say it's a domain name system. It translates human readable domain names, okay, to machine readable IP addresses or machine readable IP addresses to the domain names. So what is the requirement? For example, if I'm trying to open any website here, there is no point if I can simply try to remember like aws.console.com, amazon.com, correct? But when you are trying to go with the networking terms, this domain name system has to be linked within some IP address, correct? So that IP address is actually tried to connect to a server where that IP address and the application is hosted. So it is not possible for humans to understand and remember the IP address. I cannot try to load an IP address like 192.162.7.1, right? I cannot try to give that to customers or the clients. Hey, this is my AWS console IP address. Just try to remember this. And this IP address can change anytime. So what actually it comes in, the DNS plays an important role. What happens? It will try to convert this IP address to the domain name systems that will be able to understandable for humans just for easy understanding. Okay. So it just translates human friendly domain names to the machine IP addresses. We have a different characters as well. Okay. Yes, correct. It translates the IP address to the characters. That is nothing but a DNS. So this domain name system. What is DHCP? It's a dynamic host configuration protocol. Why this dynamic host DHCP is needed? For example, you can see these terms over here. You see, I have a DNS as well here. DNS, right? My computer has been assigned with my company's DNS by default. So every company or any organizations, they'll try to keep their own DNS server that will be converting this particular IP address mechanism to a domain name. So it has been assigned with some DNS server. You can see, I can try to find out. In the same way, I also have a DHCP enabled. You can see DHCP enabled. What is the requirement for a DHCP? For example, if I try to click on this, it is a dynamic host configuration protocol. So DHCP is a concept. It is nothing but assignment of a IP address in an automatic state. Okay. It will try to automatically assign the IP address to your computer. So how it is going to be? Try to open a general network in my computer, for example. You can see there are options here. So this is my internet protocol version, TCP IPv4. Because we are using IPv4 here, I doesn't have a DNS configured because it has been automatically assigned by my company about the DNS server. You can see this is the DNS server. That's why it is telling obtain DNS server address automatically. So when I'm trying to connect to my computer, it has been automatically assigned to a DNS server. It has been automatically connected to my DNS server given by my company. For example, even this is nothing but a DHCP setting. What is DNS setting? Obtain IP address automatically. It means it is trying to automatically assign IP address to your computer. Or if you try to assign a manual IP address, you can try to enter here. Okay. So how it is going to be assigned? You can try to click on the IP address, subnet mask, default gateway, and everything so that you can have an access to your internet. So for example, in a big companies where they want to assign IP address to your computer. Okay. So there are 100 systems. What happens? You have to go to each system and go type IP address, subnet mask, and the default gateway so that you will get an access over the internet and everything. So it will be a tough job, correct? So there, DHCP is a concept which comes into picture where it will be once you are trying to switch on your computer or the laptop at your home. I can say maybe your home doesn't have a DHCP though. So you can try to see if you are working in a company, when you are trying to sit over in the company or any institute, like you might have gone through some kind of a software institutes or anything, right? Where you're trying to open your computer, connect your LAN cable. So you might see once you're connected to a LAN cable or the LAN port is glowing on with an orange color LED lights, right? So that means then the communication is happening from that cable to your computer. So what happens? Immediately once you're trying to connect your LAN cable to your computer, it will be trying to assign an automatic IP address to your computer. So that is actually happening with the process of a DHCP here. So it is happening with an automatic IP address allocations. So that has to be done with your company or the organization which is trying to take care. What actually they are trying to do, rather than trying to enter a manual IP address to your computers, they are trying to put a group of IP address into some server. So what happens if they try to put a group of IP addresses, like 100 IP addresses into that server, DHCP server? Once you connect a LAN cable to your computer, then your computer will get an automatic IP address assigned. It's because of DHCP technology. Okay. So these are again the different terms which has been there. You can try to refer more through online as well. Any doubts on understanding till now? These are kind of a basics, important basics which you need to go through. Okay. So let us try to go with others as well. Now, what else are left? Actually, these are kind of a basic terms which you can try to see that. And let us try to understand CIDR as well. There is one more concept, which is nothing but a CIDR. Nothing but a classless inter-domain routing. CIDR is nothing but a classless inter-domain routing. It is nothing but a group of IP addresses that are allocated to the customer or user when they demand a fixed number of IP addresses. It is kind of a concept where if we being an admins or administrators, where if we have to assign IP addresses, okay, so then we'll try to divide those IP addresses to make sure there are no wastage of IP addresses. Okay, in CIDR, there are no wastage of IP addresses as compared to the classful addressing, because so if a customer is trying to request, I need these many IP addresses to be assigned to my network, a kind of a group of systems, then we are trying to follow the CIDR concept here. That's why you're trying to call this classless inter-domain routing. So how this it is going to be divided, for example, you might have seen, right? The IP address is actually denoted with some kind of a 192.168.9.3 slash. It will be denoted by some kind of a notation. Okay, some kind of a 23 and /18 and /24. What are the /24s? Okay, let us try to see that. So this is nothing but a subnetting concept. What is meant by subnetting? A subnet or a subnetwork. It's kind of a logical division of an IP network. For example, we cannot use a single IP address, correct, to your computer, because in this whole world, we have seen these are the IP addresses which are available, correct? So these are around the IP addresses which are available from 0 to 254. So If you try to divide and rotate between these 4 octets like 192, 168 and 242 to 232 and 3, these are not actually enough for the entire world to operate with these IP addresses, because if one IP address has been assigned to your computer, so other person cannot be used it. Correct? So that is a problem with an IP address consuming. So that's why this networking concept in this cloud networking concept, they have been coming with a concept called subnetting. So this is nothing but a subnetwork. So subnetwork is nothing but we are trying to divide. So we are trying to divide the main network that has been given into a subnetwork, so that logically we are trying to divide that. So we are trying to divide the main network into subnetworks logically. It's a logical subdivision of an IP address. So into 2 or more networks, that is nothing called as a subnetting. Okay. Yes. So a subnet is concept that is actually trying to divide the main network into subnetwork, right? For example, I purchased around 5 public IPs. Why 5 public IPs are required? For example, I have a company, I have a public IPs, I try to purchase from the ISP. That is nothing for internet service provider. So these 5 public IPs are actually required, which can try to give you an internet access so that you can try to download the content. So these 5 IP public IP addresses are given by ISP. So there are actually 100 systems, 100 computers. So you do think how these 5 public IP addresses are actually enough to have an internet communication enabled for 500 computers in a company? It is not possible. So that's why what they are trying to do, they are logically dividing these 5 public IPs with the help of this subnetting concept with these slash notations, so that with the help of a network bits and the host bits. So they are trying to logically divide this with the help of a subnetting concept, so that all these 100 computers will get a public access over the internet. Okay. So that's how it is trying to work on. It's kind of this concept is kind of an ocean. This networking, this concept is kind of an ocean. It will be more interesting and as a technical when you try to go through in depth. Okay. So it is trying to have the communication enabled with the help of a subnetting concept. So that's when it will come with a subnetting concept with a slash notation. You can see the slash notation, right? So let us try to see how this slash notation will be defined. For example, okay, let us try to understand how this slash notation will come into picture and how this is going to helpful and how we can try to divide how many IP addresses are available for this slash notation. Okay. So let me try to see, for example, if any IP addresses, for example, this has been given with a /8. This has been given with a /16. This has been given with a /24. Okay, for example, 192 dot, like any IP address you can see, 172.168.137. This is, I'm just trying to take a random IP address over here. 145.262. This is kind of a 4-octet IP address, correct? It has a 4 octets, right? Now, each octet has a 8 bits. For example, here with a binary numbers like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it can be zeros and ones. Okay. 1 can be a network bit and 0 can be a host bit. So it can be defined with it kind of an 8-octet bits. So each bit has an 8 octets over here. So when you try to multiply with the power of 2, each octet will come under with a subnet mask of 255 dot, 255 dot, 255 dot, 255. Okay, these are the octets which is coming into. So that means each octet has maximum of 255 bits. This octet has a second octet has a 255 bits. Third octet will have a 255 bits. Fourth octet will have a 255 bits. So that's how it is coming in. So for example, if I'm trying to use here /8, okay. So that means here I'm trying to use /8 for the first one. For example, I'm trying to take this as an example over here. Here I'm trying to tell this particular bit has been divided with 255. As I told you, it's a 4-octet, right? Each octet will have a 255.255.255.255. For example, if I'm trying to use this first octet as a /8, that means I'm trying to completely utilize this first octet because it has a /8 notation. So it will be occupied with this 255. Then remaining 3 octets will be 0.0.0, 0.0.0. Okay. So if I'm trying to act it as a, because it is an 8-bit, right? So that's why I'm trying to call it as an 8. If I'm trying to call as a 16-bit, so first 2 octets will be filled. That means these 2 octets will be filled. So how it is will be filled? Then I'm trying to mention as 255.255.0.0. That means /8 means the first octet will be completely used, right? Because it will have an 8 bits. So that's why I'm trying to tell /8. So another octet will also full, then means 8 plus 8 equal to 16. So these 2 octets will be 4. So the next available octets I can try to use is 0.0. In the first example, I'm trying to use 3 octets. And the second example, I'm trying to use these 2 octets. That means these 3 are useful to utilize. And these last 2 octets are useful to utilize. That means these are full and these can be used. This is full and these can be utilized full. Okay. And for example, the 4th octet, it means 8 plus 8 plus 8. 8 plus 8, 16, and 16 plus 8 equal to 24. That means 255.255.255.0. Okay. So here I'm trying to utilize all first 3 octets and the last 3 octet is left for use. So that's why I'm telling as 0. Okay. Here 8, 16, 24. That means the first octet is actually, I'm trying to block that as a 255 and the remaining 3 octets can be utilized to division of IP address with the help of a subnetting. So here the 3 octets, the 2 octets are useful and the last 2 octets I'm trying to have that for consumed for the subnetting concept. And here also 8 plus 8 plus 8. So 24 bits has been utilized. So that's what I'm trying to mention as a /24. So this is mentioned with the full 255 IP address, 255 IP addresses, and the last bit can be used as a host. This is nothing but a networking bit. These are nothing but a host bits. These are network bits and these 2 are host bits. These 3 are network bits. This one is a host bit. Okay. So now how many IP addresses are actually available when you are trying to utilize as /8, /16, /24? Let us try to calculate that. Okay. Let us try to see. So here, let us try to see. So if you can see, this first octet is actually utilized with a 255, right? So I'm trying to use with the last 3 octets. Then it can be configured as 255. How many are left? 3, right? How many are left? Let us try to do a calculation. You can see this first octet actually already been used. So I can try to use only these 3 octets. So then I can try to multiply these with 0.0.0, right? So this is left with the 25, 255 into 255 into 255. So if you try to calculate how many IP addresses are available, let us try to see. 255 into. So how many IP addresses are available here? 16 million IP addresses are available, right? You can see this example. These are 16 million IP addresses are available over here to use. So that I can try to tell IP addresses are available. So if I try to go with the second example as well, the first 2 octets are the network bits and the last 2 octets I can try to use and try to divide the IP addresses to the computers. Then I need to mention as 255 into 255. It is coming around 65,000 IP addresses are available here. If I try to use /16 notation, okay, by seeing this notation, you will need to actually try to have a calculation that these many IP addresses are available with a / notation and /16, these many IP addresses are available. Like 65,000 IP addresses are available. If I go with a /24, how many are there? It's only one octet is pending. So then it is available only with the 255 IP addresses. So based on the requirement, like based on the need of the project, how many IP addresses are required, you will need to do a subnetting concept. With the help of this slash notation, you will be determined, and you can try to divide that with the help of a slash notation with these calculations. Okay, that's how the CIDR blocks comes into picture, where you can try to calculate, where with the help of a class interdomain routing, you can try to calculate with the help of this thing. So you can see these are kind of an IP address, right? 0.0.0.0/0. That means all IP addresses are available. Okay. So if you try to go with an 10.22.33.44/32, that means /32 has a notation where you can try to use, it has a different set of IP addresses which are available. /24, we can try to see how many are available. We have seen that, right? /24, we have 255 IP addresses are available here. In the same way, /16. That means the first two octets are blocked, and the last two octets you can try to divide it. So these last two octets you can try to divide with the slash notation, so that you have around 65,000 IP addresses are available, so that you can try to divide that. So you can see the right side example. /28, you have a 16 IP addresses are available. /20, you have 4,096 IP addresses are available. /19, 8,192. /18, 16,384. /17, 32,768 IP addresses are available, and /16, 65,536 IP addresses are available. Okay. So if you would like to perform more calculations of IP addresses like through a subnetting, we have a subnet calculator over the online that will help us to calculate IP addresses ranges and trying to divide with the different classes. You can see, if I try to have a calculation for some IP addresses, this is an IP address. I want to divide with some kind of a slash notation. Slash notation is /30. So these are different IP addresses which are available. So we have 64 possible IP addresses available with a /30. You can see how these IP addresses are ranges. I can try to give 64 systems to a different IP addresses like 125.0, 125.50.2.4 until the end 125.50.217.252. That means I have 64 IP addresses that has been divided from the main network. This is a main network. So I can try to divide these networks, assign these IP addresses to a different computers to have an access. Okay. So this is how the networking, the IP addresses can be divided with the help of a subnetting concept, with the help of a classless interdomain router. Okay. So these are like pretty basic things that's actually having a requirement to have this coverage, to have assignment of an IP address to a different devices as well. Okay. Yes, if we have a purchase an IP address, we can try to have a virtual logical division of a network to a 64. Yes, correct. If you try to purchase one public IP, you can try to use it for a different set of IP addresses based on this requirement. Like, for example, if you purchase one IP address, then how many computers you had? Like, for example, I had a requirement for around 100 computers. Then I can try to do a /24 IP address logical division, because I have one IP address. I have a requirement for around 100 systems. Then there is no point of trying to grab 65,000 IP addresses, right? Then I can try to choose /24. Okay. So if I have more than 255 IP addresses, if I have more than 255 computers in my company, then I cannot try to use /24. Then I can try to actually go with a lower number like /20, /16 or /18, because more number of slash notation, that will be less number of IP address available. You can see the more number of slash notation, you will have a less number of IPs. For example, I have around 15 systems. Then I can try to go with a /28 notation. If I have around maybe 9,000 computers, 9,000 system IP address are needed, then I will go with a /19, because /19 will give me 8,192 IP addresses. Okay. The lesser the number of CADR value, the more number of IP address will get. The higher the value of CADR value, the lesser number of IP address you'll get. Okay. That is how the calculation should be done. So you'll try to go with a more understanding if you go through online, the subnetting concept of the online, you can try to have a subnet calculators as well, understand more on the subnetting calculations. So the reason I'm trying to tell, because we'll try to see the same examples within the cloud environment as well. We'll try to divide this network, like it will be giving, the cloud is trying to give us a CADR block. With that, we'll try to create a network as well. Okay. And what else we have? So if you try to actually go with that, within the AWS, we have a different options like elastic IP address, the terms which you see will within the console. So that's why I'm trying to mention that before you, so that you won't get confused. Subnets and route tables, NAT gateway, security groups, network ACLs, IGW. This is nothing but an internet gateway. These are the terms you'll see inside the VPC, virtual private gateway. All right. So elastic IP address is nothing but a public IP address. Okay. That you are going to see that once we are trying to do a lab session. Subnetting, as we have discussed, is nothing but a logical division of a networks. Public and private. Route tables. So route table is nothing but a general kind of a router. Okay, it's simply as simple as router. So what it does, virtually we are trying to call this as a route tables. In general, what does the router do usually? It is trying to control the traffics where it will try to show the route where the traffic has to go. And even at your home, if your computer is connected to a Wi-Fi device, which is connected through a router, what the router is trying to do, it is trying to control the traffic and trying to route the direction where the traffic has to be diverted. So that is trying to pass the internet from your router to a computer, right? That's as simple as that. So route table controls where the traffic has to be directed. Okay. So NAT gateway is nothing but network address translation. Okay, we'll try to go through more through this when you are trying to go with the NAT gateway concept inside. So what actually it is trying to do? It is trying to mask the private IP address and having a public internet access to the server. This is one kind of a concept. What is a security group? You remember when we are trying to launch a server, we are trying to enable HTTP port, HTTPS port, right? And the TCP ports and everything are there. So security group is nothing but it is trying to restrict the access to have a communication over the internet. Restrict the access defined with the ports which is having access to internet. It can be any port like HTTP port, HTTPS, DNS, TCP, and SSH ports, right? So we have seen during the launching of a server. Hope you people might have an idea. So those are actually coming under security groups which are managed under the VPCs. Network ACL is nothing but an access control list. So what we are calling this as network access control list. Controls list, which acts as a firewall for controlling traffic. Okay, it will trying to act as a firewall which will control the traffic for the servers or the infrastructure. IGW is nothing but a internet gateway. Why it is needed? It is trying to provide the internet access to the public subnets. Okay, so that servers will get a public internet. We'll try to see that while we are trying to do a lab session. It is used to provide public internet. Gateway is nothing but it's kind of a medium. It is kind of a transferring kind of a location where it is trying to mediate the location from one location to another location, enabling the communication from one location to another location. Okay. So, but internet gateway is a concept where it is trying to show the path for to have an access to the internet. Okay. So this will act as a medium. It is used to provide public internet access for public subnets so that EC2 servers can communicate over the internet. Okay. So these are the different terminologies you will try to see when I'm trying to go with a console like AWS console. So the reason I'm trying to tell these because if I'm trying to go with a lab session, it doesn't make sense like without understanding these concepts, right? So that's what I'm trying to tell you in beforehand. So why these things are coming in, what are the different terms available within the VPC? Okay. So these are different options which are available. So what we can do, we'll try to go with a VPC service and how it looks like first. Okay. You can see this is a VPC. This is a thing, dashboard and the console, how it looks like. This is a VPC console, how it looks like when we try to log in, and you can see different options over here like VPCs, subnets, the route tables, internet gateways, NAT gateways, peering, network, security groups, all things which are there, right? So that's what we are trying to understand over there. Okay. So let us try to understand more theoretical background before we jump into the lab session. Okay. So, all right. So what is Amazon VPC? Amazon Virtual Private Cloud. It enables you to launch AWS resources into a virtual network that you define. So you can try to launch all the resources like servers and the applications and any softwares or any devices or any mediums that has been launched through a virtual private cloud through a network that we are trying to define. Correct? This virtual network closely resembles a traditional network that you would operate in your own data center with the benefits of using the scalable infrastructure of AWS. Like unlike we are trying to use a real-time environment, like how in the on-premise environment or the physical infrastructure, how network used to be there with the router, switches, and the firewalls. It's kind of an access points and the Wi-Fi devices. That is kind of a physical architecture and the physical devices, right? In the same way, traditionally the cloud environment provides the virtual networks, how it is trying to be replaced. Okay, let us try to see that. So where we can try to deploy this virtual private cloud, you can deploy a virtual private cloud in any AWS region. Okay, we have different regions, and by choosing the required region, you can try to deploy the VPC in any region. A VPC can host supported resources from inavailability zone within its region. So once you try to deploy a VPC, that network can be available within all the availability data centers like Zone A, Zone B, and Zone C, like US West 2, US East 2. If you're trying to deploy in particular region, so all the devices that can be communicated within that particular availability zone. Okay, that's what this picture is trying to explain us. So how we can try to divide this VPC? You can see this as we have just now, we have tried to go with the theoretical understanding of this particular VPCs. Dividing your VPC, how it can be divided. The network can be divided with the concept of subnet, which I've told you just now. The subnet is a segment of a partition of a VPC's IP address range where you can allocate a group of resources. Okay. So subnet is a thing where you can try to divide the IP addresses, and so that you can try to divide those IP addresses during the subnetting to a different servers of the resources. The subnets are not isolation boundaries. Subnets are a subset of the VPC CADR block. So subnets doesn't have any boundaries within that network. That means it doesn't have any restrictions when it is divided under the CADR block. So it's a subset of the VPC CADR block. That means if I'm trying to choose, for example, if I'm trying to divide this particular subnet, right? For example, it is something like 192.168.0.0 slash /16 maybe, for example. Okay. So what happens here? I'm trying to use this as a block where I'm trying to use /16 notations. So what it is trying to do? It is a subset of a VCR CADR block. That means if I'm trying to divide these particular /16, I means I have 65,000 IP addresses are available. So that means I can try to divide this with 192.168. I can try to have this keep remain same. These first two octets will be same, and these remaining two objects will be keep on changing that host bits, like 1.1 and 1.3. It's kind of a set of combinations, 1.3 and till the 1.255. In the same way, I can try to mention as 2.0 and 2.1 until 2.255. That is the maximum, right? So 2.5, 2.255. In the same way, I can try to utilize till 255.255 maybe. So that's how the division can be happening. 1 into 2.168. The last two digits will be keep on changing because those are host bits. So I can try to utilize all this particular IP address range till 65,000 till that are available. It is kind of a subset of that particular CADR block. Subnet CADR blocks cannot overlap. So once the IP address is used for one block, that cannot be overlapped with another IP address block. So it can be used at once. That's what it means. Each subnet resides entirely with one availability zone. So it is trying to tell that it is completely resides with one availability zone with that has been completely blocked. So that another availability zone cannot be trying to utilize with the same overlap of the same IP address range. Okay. So AWS reserves 5 IP addresses in each subnet. So when we are trying to talk about each block has a maximum of 255 IP addresses, right? So that means 192.168.0.1 to 168. Till 1.255. That means we cannot try to use 250.255. It might be a 254, something like that. Okay. Because AWS is trying to block some IP addresses from some system specific requirements in the backend. So it might be 254. So there are 5 IP addresses which are actually reserved by default in each subnet for some system level purposes. So that's what it means. So it doesn't mean like 1 to 255 are completely utilized for our usage. So out of 1 to 255, there are 5 IP addresses are actually blocked. Okay. That is blocked by AWS actually. And you can see this picture, and availability zone 1 and availability zone 2. And you can see they have tried to choose 10.0.0.0/22. Okay. So 22 means how many IP addresses are available? Actually, you can see 251 IP addresses are available. Okay. 255 IP addresses are available. And from these 250 IP addresses, I can try to allocate 251 IP addresses to all the servers. And these remaining 4 IP addresses are actually reserved by AWS for some other purpose. Okay. So /22, it has been divided in such a way that these IP addresses are available. So I'm trying to create 2 public subnets and 2 private subnets, and these IP addresses are dividing accordingly. Okay. So a VPC with CADR /22, it includes 1024 total IP addresses. So these 1024 IP addresses are divided /4. That means with the help of a subnet, I'm trying to create 4 subnets like 1, 2, 3, 4. These 4 subnets are divided with 1024. So each subnet will get 251 IP addresses. This subnet will get 251 IP addresses. This subnet will get 251 IP addresses. So these are divided in such a way, right? So you can see 1024. So we have maximum of 256. That means out of 256, I'm trying to minus 4 maybe, because those 4 actually used for some other resort for IP purpose, like 5. So how many are left? 251 IP addresses are left. So these 251 IP addresses can be assigned to a servers. Okay, we'll try to see in a lab session that will give a more clarity on how it can work. Okay. So what are the best practices VPCs? Best practices. Okay, virtual private cloud. We'll try to create that as well. Create one subnet per available zone for each group of hosts that have a unique routing requirements. So when you are trying to create a virtual private cloud, we need to create at least one subnet for availability zone. Okay, so that it has a routing requirements and to go with the routing rules. Divide your VPC network range evenly across all availability zones in a region. So you can see how this has been divided. it has been evenly divided over here. When I'm trying to choose this 10.0.0/network, I'm having a 1024 IP addresses available. So I'm trying to divide evenly to all the subnets, like 4 subnets evenly. That means I'm trying to get equal IP addresses for all the subnets. Okay. We'll try to do the same lab session as well. Do not allocate all network addresses at once. Instead, ensure that you reserve some addresses spaces for future use. So it is trying to tell reserve some IP addresses for future purpose for any other requirement, just to make sure for any other important aspects that you want to assign to a servers. Size your VPC, CIDR and subnets to support significant growth for the expected workloads. Okay. So what it is trying to do, based on the project requirement, based on the number of servers you launch, we need to make ensure that have a proper calculations. So if I have a requirement of a 100 IP addresses, I doesn't require a /16 notation, because /16 will give me 16,000 IP addresses. There is no need for higher level IP addresses. So for what I'll try to do, I'll do with a /24 subnet mask. If I try to do a /24, I'll have a 255 IP addresses, right? I'll go with the least. I'll go with the least one. So maybe I can try to go with a /28. Then I might get around 160 IP addresses available. So this is how the calculation should be done wisely. That's what it is trying to tell. Ensure that your VPC network range does not overlap with your organization's other private network ranges. As I told you, during the CIDR block, there should not be overlap. There should not be same IP address assigned to each subnet. So otherwise, it will show you an overlap error. That is a mandatory requirement. For example, let me try to create a sample VPC, how it is going to work out. Okay. Create VPC. Now, what actually I'm trying to do, it is giving me an options to create VPC. What it is trying to do, either I can try to create a manual VPC settings over here by myself, like I can try to manually assign IP addresses and everything within the VPC, or else I can try to go with an automation over here. Okay, let me try to create a project VPC here. What it is trying to do, whatever the defined values I'm trying to click here, it will try to give an automatic values. You can see, I'll try to create a project VPC. Here, what are the subnets are available? It is trying to give, I'm trying to create inside Oregon region into 2 data centers. You can see US West 2 and US West 2B. Okay. So each subnet, how many are actually available? You can see I'm trying to create public subnet and the private subnet. What is the requirement of a public subnet and the private subnet? As I told you, how the private and public IP address matters. Private IP addresses are actually required to have an internal communication. Public IP address to have a communication over the internet. Correct? So public subnet is actually useful to have an internet communication so that you will get a public IP address. Private subnet is actually useful to have a private IP address assigned to a computer. So that's why in this region, it has been assigned with a public subnet and the private subnet. In the West 2B data center availability zone as well, I'm trying to create public subnet and the private subnet. Okay. And in the similar way, you can see there has been created with the route tables. The route table has been created. What is the need of a route table here? I told you, right? A route table controls where the traffic has to be redirected. It is nothing but similar to a router concept at our home as well. It will try to show the traffic where it has to be routed. So the subnets, once it is configured, this information will be configured inside this route table. So you can see route table public, and this there has been created with the 2 different route tables that has been configured here. And then to have an internet communication enabled, what is required? As I told you, internet gateway is required. It is used to provide the public internet access for the public subnet so that EC2 servers can communicate over the internet. So it has been connected through an IGW. It is nothing but an internet gateway. Okay. So let me try to create an automated VPC. So how it is going to be helpful? For example, you can see 10.0.0.0/16, right? For example, so as per the slide, what is the range it has been chosen here? For example, 10.0.0.0/22. Okay. Let me try to create the same one here. We'll go with the 22. Okay, I'm trying to go with the 22 concept here. And how many subnetworks are required here? Here in the concept, they have chosen 4 subnetworks, right? 1, 2, 3, 4. No, actually, one region has 1 public subnet, 1 private subnet. 1 public subnet, 1 private subnet. That means 2 to each, correct? Let me try to go with a 2 here. In the same way here, you can see, I'm trying to choose 2 availability zones as with the slide. This means one availability zone here, one availability zone here. That means I'm trying to select two availability zones here. How many public subnets are needed in each availability zone? That means two subnets here, two private subnets, the two public subnets. You can see in the same way, right? Two public subnets, two private subnets. Let's see here. Now, NAT gateway is not required because you need to understand first this concept. I'll let you know about the NAT gateway soon. And nothing here. And what actually is needed, DNS hostname is needed, DNS resolution is needed. I'm trying to create a project VPC, for example. Okay. How many are available, guys? You can see the same which I'm trying to show you in theoretical explanation. 1024 IP addresses are available because /22 will give you 1024 IP addresses. Okay. /22, it will give you 1024 IP addresses when we are trying to do a subnetting concept. And out of this 1024, we are trying to equally divide those IP addresses to these 4 subnets. Okay. So when we are dividing each 4 subnets, you'll get 256 IP addresses. So out of 256 in each subnet, we are reserving 5 IP addresses. AWS will automatically reserve 5 IP addresses in each subnet. Okay. Let us go with the create. You can see it is trying to create automatically, but this is for, I'm trying to show you for understanding purpose, but I'll try to show you practically on creating each and every value in the next lab session. Okay. So simply this has been created, VPC, DNS name, and all the 4 subnets has been created, internet gateway has been created, route tables has been created. And let me try to click on the view VPC now. If I go to the VPCs here, try to relate the same concept which I'm trying to teach you as per the slide as well. AWS project VPC has been created. Okay. You can see AWS project VPC has been created. See, this is the name that has been given by Amazon. This has been generated within a VPC ID. This is available. What is the slash notation here? Yes, we have created a project VPC. /16 has been created. Okay. Now, this is the public IP address. For example, as per the concept I told you since from beginning, I purchased a public IP address like /16 from the internet service provider. Now, I got around 1024 IP addresses, correct? Now, I'm trying to do a subnet mask and I'm trying to do a virtual division with the help of a subnetting concept. I'm trying to divide with the subnets here. So that is what I'm trying to do here. With the subnet mask, subnetting concept, I'm trying to do a virtual project. Okay. AWS project. You can try to relate the theoretical understanding how we try to discuss, right? With the help of this /16, I'm trying to divide all these virtual subnet nodes so that these out of the subnetworks, I'm trying to assign these servers to the computers. You can see this is a private subnet, public subnet, private subnet. You can see /20/20, and each has this particular available IP addresses. You can see how this has been divided over here. This has been created with a route table. This has been route tables has been created here. This is nothing but a route table. Okay. And internet gateway has been attached to, so that you'll get an internet access. So what I'll try to do, I have a network ready now, correct? I'll quickly go to the EC2. I'll try to launch a server into that network. Let's see how it is going to work out. I'll go to EC2 dashboard, instances, click on launch. Okay. I am trying to launch with a VPC server. So you remember when we try to launch, we have skipped this networking section because we are trying to configure this networking section and we are trying to launch the server under that network. For example, I'm trying to launch a Windows server. Okay. I'm trying to launch a Windows server and I'm selecting the free tier, and these things are actually cleared out in the compute section. And here, when I'm trying to come to the networking section here, when my personal computer at my home, it is assigned with some kind of a private IP address. When I'm trying to get over the internet, your internet ISP provider will provide you a public IP address so that you can get internet access, correct? That's why I'm getting internet access at my computer. To get a virtual server, get internet access, you need to configure a network. So that's what I'm trying to do virtually over the cloud. When I'm clicking on edit, I'll click on AWS project VPC. You can see this is a project VPC, right? /16, you can see. So This is the main network I selected. Now, which subnet I need to select? You can see all these 4 subnets are visible here in the subnets. All these 4 subnets will be visible. All these 4 subnets are visible. So these subnets are coming from the main network 10.0.0/16. Now it is asking which subnet you want to choose. You want this server to be used as an internal and you want to have internal communication, go ahead and use private subnet. If you want this server to have a communication over the internet, go ahead and use the public subnet. Does it make sense, right, everyone? So for internal communication, you can try to use a private subnet and you can launch the server. But for the internet access, you can try to submit the public subnet. Okay. So what I'm trying to do, I'm trying to click on the public subnet. I'm giving the main network as a 10.0/16. I need an internet access so that I can try to access the Google. So I need an public IP access over the internet. So I'm trying to click on public internet, public subnet. You can see. So it will be assigning with public IP address. You can see enable, right? Now, security group, as I told you, security group will allow us to launch over the. So right now, by default, the security group is as enabled with the RDP port, right? Let us try to enable SSH port soon. And let me go with the default settings, click on launch. Let us try to see how this server actually gets launched over the network which I've created now, over the cloud. I'll go with the view all instances. Now, when you click on this particular server, you will see it has been assigned with a public IP address. As I told you, what is the purpose of the public IP address? It is used to connect to the internet so that they can retrieve, download, and share the content over the internet. So you need a public IP address. So we got a public IP address. It has been randomly, we got a public IP address from the VPC. Okay. Because I've tried to choose the public subnet. And you also got the private IP address. What is the private IP address? This is then again important. So when I'm trying to launch a VPC server, it is asking me to choose which public subnet, correct? When I'm clicking on this tab, it has been selected with AWS project subnet public 1, correct? When I'm going with AWS project subnet 1, where is that? This is the one, AWS project subnet 1. What is the range of the IP address which has been given here? 10.0.0.0/20. So from this particular subnetwork, after the division, my server has been launched out of the this /20 network. My server has been launched. You can see what is the IP address I got, 10.0.1.98. So it has been chosen out of this range 10.0.0.0. It has been chosen 10.0.0.1.48. So that's what it has been launched. You can see my private IP address has been launched from this out of this public network range. I mean, this particular subnet out of this range. Okay, that's what it is trying to show. So I got a public IP address. I got a private IP address. Okay, and I have a DNS which is actually useful to have an access and over the internet. You can see this by default DNS has been given by Amazon. Let us try to connect now. RDP client. I have a successful connection. Let me see. I need to get a password, right? Load private key file. Now I need to go with this. I have a public key. I'm decrypting the password. Now let me open the server. Now my server has been launched under a VPC which has been created by me and the network which has been defined by myself. Okay, let us try to see that. Let me see if I get a public internet access or not. My server is loading. Okay. Now, if I just go back to the main instances here, let me try to launch one more server quick with a private server. Okay. Private subnet. Right. Now earlier I tried to choose a public subnet. I'll try to launch a new server as a private, because in my company, I had a private servers and also public servers. Some servers need a private access, some servers need a public access. So that's what I'm trying to choose. Again, I need to go to the project VPC, and here I doesn't require internet because my information to be secure. No one should access my computer and there shouldn't be anyone accessing my computer. So I'm trying to select the private so that it shouldn't be visible over the public internet. Okay. And let me quickly launch this. It's launched. Okay. In the meanwhile, let's try to check the internet access here. It is telling, do you want to allow your PC over the internet? Yes. Now on the desktop, you can see it is giving us private IP address 10.0.198. So out of that 251 IP addresses, that subnet actually given this random IP address to my computer, and the public IP address, it has been given by ISP, for example, 35.91.139.19, correct? 19. So let me check the internet access over there, if I'm getting a Google response or not. I can open command prompt so that I can try to ping Google. It's quite slow. Let's give it time. In the meanwhile, let's see if another server has been launched. This is a public server. This is a private server. Okay. Just want to have a naming convention. Let me connect to this server as well. So it takes at least 3 to 4 minutes for a password to be generated. Let's give it some time. So let's see if that has been connected. You can see I'm getting a ping response to the Google. That means I can get the internet, access to the internet. Okay. So it means at the public subnet, due to the enablement of internet gateway visibility, so I'm getting an internet access to the public server, right? So let us try to go with the same thing with private server, if I am trying to able to access or not, because private means you can see there is no public IP address. Do you think that without the public IP address and without public DNS we'll get an internet? It cannot be. And now you see it got an address like 10.0.130.171. From where this IP address has been got here? From which subnet has been choose? It has been given from AWS project subnet private one. So this has been given here. So the network here has been defined 10.0.128.0/20. So which IP address has been given? 10.0.0.130.71. So out of this range, 128.0, 128.1 till 128.255, out of this range, this has been randomly given the IP address as 130.177, 171 to this private server. Okay. So if I try to connect, let me see. Okay. Let me open this as well. It is giving a prompt. It is trying to connect from my local system over the internet to this server, the server which has been hosted in the AWS. The IP address is 10.0.130.171. So it is keep on taking time. What it says, remote desktop can't connect to the remote computer for one of the reasons, because remote access to the server is not enabled, the remote computer is turned off, or remote computer is not available on the network. Why? Because it has been not given the public access. That's why I'm not able to access this private server. As simple as that. Is it clear, everyone? The reason I'm not able to connect to the private IP address because I did not given a public access to that. Okay, so that's why it is trying to show me this error. Clear? So that's why we are trying to divide these networks as internal server, secure servers, this as a public access server, so that you can try to install applications and trying to give access to the someone. But as I told you the same thing, like within this particular, I can say within this particular VPC, for example, if VPC is created into these availability data centers, all the private servers and the public servers and all the public subnets and the private subnets can communicate each other, because the subnet is in a concept of a logical division of a single network to a multiple networks, but logically that is under one network, that is one main network. So this private IP address 10.10.198 can communicate internally with private server 10.0.130.70, because all are belonging from 10. Network only, right? It is coming from the main network as 10.0.0/16. So what I'm trying to do, let me try to go to the public server here. I'll go open the remote server from there. Okay. I'll open the server inside the server and I'll try to connect this private server from here. This password. I'll open a remote desktop connection. You can see this. What is an IP address for the private server over here? 10.0.130.171, right? Let me open that. Let me connect. See, it is asking the credentials. Let's try. Administrator. And the password. Need to copy this password from my notepad. So inside the server, the public server I'm trying to access, because as per the concept in theoretical concept, as I told you, subnets inside a single VPC can communicate each other. That's what the logic, right? So let us try to check if these two servers inside can communicate each other or not. Okay. Do you copy the problem? I've just typed the wrong one. Administrator spelling is wrong. Administrator should be 1A. Now click on OK. I'm connecting a private server inside the public server, not from my local system, because private subnet and public subnets are already internally connected each other, right? Background in the virtually. So you can see I can connect the private server inside the public server, because as I told you, the subnets inside a VPC within that particular region can communicate each other. That's the concept here. You see, from my local system, when I'm trying to this computer, it is not working because the public internet access has been blocked. For example, even at your working in a company, okay, and there are 100 systems, right? So one person can actually communicate with another person within that particular company, but not outside the company. They cannot access other websites because that two computers are under the same network. That's why they are able to communicate each other. You can see this is a public server, this is a private server. They have been simply connected. This is how the logic works. Okay. So let me try to log off. Hope you people are clear with this, right? So tomorrow we'll try to do a lab sessions for manually on creating how this VPC can be created manually. We'll try to go with the step-by-step creations of route tables, VPCs, and subnets, and each and everything. That should be an interesting session as well. Okay. So I'm trying to log off. This private server again doesn't have an internet access. Okay. When I'm trying to go and ping google.com, it doesn't work. That's again the thing. So I'm back to the public server. I'll also shut down this as well. That's the thing. Any doubts? Are you people able to understand from the basic level understand to the cloud level implementation? I've just tried to put my efforts on maximum, trying to go with the basic level so that you can try to clearly understand on networking, because that's been one of the most important aspects for the IT information technology in the cloud environment as well. So I'll go with the cleanup process for now. So I'll try to terminate these servers again as I'm done with work. Any doubts, guys? I think we are done for today's session. We'll practice more tomorrow. So AWS key is, it's nothing but a key pair is for the authentication purpose. Okay. When you go to the key pairs, if you try to create a key pair, it will try to generate an ID, authentication ID. So I'll try to show you that tomorrow as well. And how to convert and how to connect a Linux. Like actually not tomorrow, maybe during the course structure, when you're trying to have that course structure taken care, like within that session, like 50 days course structure within the ExcelR, you'll be able to understand more on key pairs and in-depth concepts of this so that you can try to learn more on that. Okay, I'll try to explain you on clearing that key pairs. Because going through each session and each topics and each setting configuration, it requires a real-time batch so that you'll get a more understanding on it. So as I told you, right, because for example, this public subnet and the private subnet, these having a actually coming up from where? These actually coming from a same network, right? As I told you, for example, some people have a doubt like how this actually private and public servers are connected to each other. You can see this is a main network, right? This is a main network. This is a main network 10.0.0/22. We know that out of this /22, we are getting these many IP addresses. And we know that these IP addresses are accessible for us. And we are trying to logically divide these networks with the help of a subnetting concept. And this has been divided with 10.0.0, 1.0, 2.0, and 3.0. So that means this main network is a main concept, and out of the subnets are actually coming from main networks. So these can communicate internally each other. So that's why the server which I launched, the public server, right, 10.0.0, which I'm trying to get an internet access. But the private server, I'm not getting internet access. But logically inside, this private subnet can communicate to each other to the public subnet, and the public server can communicate with each other with the private subnet. That's actually the logic behind this subnetting concept. Okay. You can see subnets are a subset of the VPC CIDR block. Subset means it's a logical division, and these things can be communicating each other. That's the concept. All the subnets with a single VPC can communicate each other, irrespective of the public IP address access, public internet access. Okay. Any other doubts? We'll be doing a manual creation of VPC tomorrow, and we'll try to do a same lab session again. Let's see how it is going to work out. Any doubts, guys? Are we able to understand the concept for today? Yes, 50 days course is actually that will be available with ExcelR. You can connect with an admin team to have more information. All right, then. If there is no concern, then we are good to end the class for today. Thanks, everyone. We'll meet tomorrow. Bye-bye.